This is an operation and calibration of UV, visible spectrophotometer for SHIMADZU of spectrophotometer. Procedure: for operation before taking reading or scanning, ensure the following points. 1. Ensure that the instrument is clean and free from dust. 2. Ensure that the instrument is calibrated. 3. Open the sample compartment cover. 4. Ensure that the beam paths are free from object projecting into the beam path, samples are in the sample compartment and accessories are properly installed. 5. Close the compartment cover. 6. Switch on the power. 7. After initialization is completed. 8. Mode selection screen appears. Procedure of operation in photometric mode, or taking absorbance in the particular wavelength. 1. Press Go to Wavelength WL key to set the required wavelength. 2. Perform Auto Zero with blank solution by pressing Auto Zero. 3. Remove the blank solution and insert sample solution and measure the absorbance or percent transmittance at the set wavelength. 4. Press Start or Stop P key to get a printout. The second operation procedure for spectrum mode or scanning mode. 1. Spectrum mode scans a wavelength range to measure the absorbance or percent transmittance of a sample. 2. Enter the scan starting and ending wavelength in that order. 3. Perform baseline correction with blank solution by pressing Auto Zero. 4. Remove blank solution and insert sample solution in the sample cell holder. 5. Press Start or Stop. 6. The spectrum is displayed. 7. The screen displays the UV maxima at the detected wavelength, that is, the maximum absorbance at the particular wavelength. 8. The spectrum picabs at various wavelengths can be seen. 9. Press F2 to get the results once the measurement is complete. 10. Return the spectrophotometer to the mode. Switch off the printer. 11. Open the sample compartment cover and remove the cells cuvette from the holders, clean them with blank solution, then with purified water and finally with methanol. 12. While handling the cuvette, always hold them on the opaque side. 13. Close the sample compartment cover and switch off the spectrophotometer. Place silica gel bags in the cell compartment. Procedure for calibration of UV visible spectrophotometer. The procedure of a visible spectrophotometer contains 1. Control of absorbance. 2. Control of wavelength. 3. Limit of stray light. 4. Resolution power. 5. Percent transmittance of cells. Procedure for control of absorbance. 1. Triturate and dry a quantity of potassium dichromate A grade by heating to constant weight at 130 degrees Celsius. 2. Dilute 0.3 ml of sulfuric acid to 1000 ml with purified water to prepare 0.005 molar. Preparation of stock solution of potassium dichromate solution. Accurately weigh a quantity of about 60 mg plus minus 3 mg into a 100 ml volumetric flask. Add 0.005 molar sulfuric acid to dissolve and dilute up to the mark. Use this solution for measurement at wavelength 430 nanometers. Then determine the absorbance using 0.005 molar sulfuric acid as a blank. Calculate the value A1%, 1 cm as per the following formula. After taking the absorbance at 430 nanometers, take stock solution of potassium dichromate solution. Dilute 10 ml of solution into 100 ml volumetric flask with 0.005 molar sulfuric acid solution, for measurement at wavelengths 235, 257, 313 and 350 nanometers. And determine the absorbance using 0.005 m sulfuric acid as a blank. Take absorbance at each wavelength and take the print. Calculate the value A1%, 1 cm as per the following formula. Check the value of A1%, 1 cm at each wavelength against the acceptance criteria as given below. Acceptance criteria for control of absorbance are: for 235 nanometers, the acceptance A1%, 1 cm is 122.9 to 126.2. For 257 nanometers, the acceptance A1%, 1 cm is 142.8 to 146.2. For 313 nanometers, the acceptance A1%, 1 cm is 47.0 to 50.3. For 350 nanometers, the acceptance A1%, 1 cm is 105.6 to 109.0. For 430 nanometers, the acceptance A1%, 1 cm is 15.7 to 16.1. Record the actual value in calibration record of UV visible spectrophotometer. Procedure for calibration of control of wavelength. Preparation of 1.4 molar perchloric acid. Dilute 11.5 milliliters of perchloric acid 70% weight by weight to 100 milliliters with water. Then dissolve 0.4 g of holmium oxide analytical grade in 5 milliliters of 1.4 m perchloric acid with the aid of heating on a water bath. Cool and dilute to 10 milliliters with the same solvent. 4% with V-holmium perchlorate solution or use ready-made solution of holmium perchlorate solution. Scan the solution using 1.4 m perchloric acid as a blank using the following instrument parameters and take the print. Instrument parameters. Scanning range. Start wavelength, 600.0 nanometer. End wavelength, 200.0 nanometer. Number of scan, 1. Measurement mode ABS. Scan speed fast. Note down the maxima observed in the calibration data sheet. Check the maxima observed against the acceptance criteria given below. Wavelength for wavelength 241.15 nanometers. The maximum tolerance is 240.15 to 242.15 nanometer. For wavelength 287.15 nanometers. The maximum tolerance is 286.15 to 288.15 nanometers. For wavelength 361.50 nanometers. The maximum tolerance is 360.50 to 362.50 nanometer. For wavelength 486.00 nanometer. The maximum tolerance is 483.00 to 489.00 nanometer. For wavelength 536. 30 nanometers. The maximum tolerance is 533.30 to 539.30 nanometers. Calibration procedure for limit of stray light. Measure the absorbance of 1.2% potassium chloride solution in water between 195 nanometers to 220 nanometers using water as reference liquid and take the print. The resulting absorbance should be greater than 2.0 at a wavelength between 198 nanometers to 202 nanometers. Record the actual value in calibration record of UV visible spectrophotometer. Calibration procedure for resolution power. Record the spectrum in the range 260 to 275 nanometers of 0.020% VV toluene in hexane using hexane in the reference cell and take the print. Acceptance criteria. The ratio of the absorbance at the maximum at about 269 nanometers to that at the minimum at about 266 nanometers is not less than 1.5. Calibration for resolution power. Second derivative. Scan and record the second derivative spectrum in the range 255 to 275 nanometers of 0.020% VV toluene in methanol using methanol in the reference cell. After scan, go to data processing, click on derivative and put value 2 inches order, then enter and again press enter. And take the print. Acceptance criteria: a small negative extremum located between two large negative extrema at about 261.0 and 268.0 nanometers should be clearly visible. The ratio A and B is not less than 0.2. Record the actual value in calibration record of UV visible spectrophotometer. Procedure for calibration of percent transmittance of cells. Firstly, set the instrument parameters as given below. Wavelength program, wavelength 240, 220, 200 nm, number of cycles, 1 measurement mode %T. Click on Auto 0 with air blank in both the cell holders, that is with both the cell holders empty. Then place one cell in the sample compartment filled with purified water using air blank as the reference and read the transmittance. Next, place the other cell in the sample compartment filled with purified water using air blank as reference and read the transmittance and record the transmittance at 200, 220, 240 nanometers wavelengths individually and take print. Note: before using new cell, percent transmittance of cell parameter to be performed and record shall be maintained manually. Acceptance criteria: the percent transmittance for all the set of wavelength should not less than 80%.